Okay, so we're going to keep continuing on with our double displacement reactions. So now we're going to see some different special cases for double displacement reactions. So once again, you need to make sure that you know the proper form of a double displacement reaction. But now in grade 11, we're going to see some special cases. Okay, so let's take a look over here at this top portion. Okay, many double displacement reactions will produce a precipitate. Okay, now once again, a precipitate is a solid. Now, if both of your products would be aqueous, then no reaction will take place. Okay, double displacement reactions can produce gases as well as liquids. Okay, now, so what we're going to do is we're going to go through some different examples and you're going to understand what I mean by this. Okay, so let's take a look at this example 2 underneath. It says, write a balanced chemical equation for the reaction of copper 2 nitrate and sodium hydroxide. Okay, so what we're going to do, once again, the first thing always when doing this reaction or this type of question is we need to write out what we have. Okay, so I don't have enough room here, so I'm going to do it on a sheet of paper. So I have copper 2 nitrate. So copper 2 means that we have Cu2+, that's what that means there. And nitrate is NO3 negative. So when we do our crisscross, we're going to get Cu bracket NO3. And we're going to close our bracket with a 2. We're also going to have sodium hydroxide. So sodium is Na, it's 1+. Hydroxide is OH, 1 negative. So when we do our crisscross again, we get NaOH. And what we're going to be making is, well, copper and hydroxide will come together. Once again, the switch happens between the positives or the negatives, but the same kind of switching. So I'm going to say that copper and hydroxide come together. So I'm still going to have copper 2+, because that's not changing, OH 1 negative, and I'd get Cu bracket OH 2. And I also would get sodium mixing with my nitrate, which is NO3 1 negative. So I'd get NaNO3. So once again, here is my layout for my double displacement reactions. Okay, the next thing that we're going to be checking is we're going to figure out all the states for each one. Once again, how we do that is by looking at this sheet here. Okay, so for the first one, we have copper 2 nitrate. Okay, so nitrate is over here. Most of them are soluble. So whenever you see that nitrate, we know that we're going to have an aqueous compound. Okay, I have another nitrate, over here. So that one is also aqueous. Okay, next we could take a look at sodium hydroxide and copper hydroxide. So if I'm looking at my hydroxides, which are over here, okay, so alkali ions, well, sodium is an alkali metal. So that one corresponds to this one here. So this one is soluble. So this one here is aqueous. Now I need to look for copper hydroxide. So if I take a look here, alkali metals, oh sorry, I'm in the wrong one, hydroxide is right underneath. I have alkali metals. None of these here correspond to copper, so copper has to be all others. So it's going to be low solubility, which means that copper here is my solid. Okay. Now, after you've done this, obviously we need to balance our equation. So I see 1 copper on this side, 1 copper on that side, so we're okay. I see 2 nitrates over here, so I need 2 nitrates there. So I need to put a 2 in the front. Now, because I have 2 nitrates, I also have 2 sodiums, so I need to put a 2 in front of this sodium. I have 2 hydroxides now, so I also have 2 hydroxides. So my equation here is balanced. Okay, so I want to go back to our lesson because in our lesson, there's a couple key points that we need to remember. Okay, when we're doing a double displacement reaction, we will only, okay, please write this down somewhere. We will only have a reaction if one of our products are either aqueous, or sorry, if our products are either solid, a liquid, or a gas, we need one of those three to be produced in order to have a reaction. Okay, so I'm going to say this again. One of your products needs to be a solid, a liquid, or a gas for a reaction to happen for double displacements only. Okay, if both of your products are aqueous, then we have no reaction. Okay, so you want to put a star beside that. Okay, so if we go back to this question here, well, if I look at my products, I don't need to worry about my reactants. It's my products that I'm worried about. We need a solid, a liquid, or a gas to be produced. Now, because we have a solid being produced, this reaction will happen. Okay, this is what we call a precipitate reaction because we're making a solid. This solid is what we call the precipitate. Okay, so let's try another example so that we can see the opposite. Okay, so let's try another one here. So we'll have calcium bromide, and we'll have potassium hydroxide being mixed. Again, I think I added too many T's there. Okay. So what I want you to do right now is I want you to pause the video and I want you to come up with the full equation. Okay. Come up with the full equation. Come up with all your states and balance this equation. Okay. Once you're done that, resume the video and we'll see if you got this correct. Okay. So try that now. Okay, so hopefully you paused the video, hopefully you tried it out. Let's go through this, let's see how you did. So once again, the first thing I need to do is I need to come up with my equation here. So calcium is a 2+, bromine is a 1-. So after I do my crisscross, I would get CaBr2. Next, I have potassium hydroxide. Potassium is a 1+, hydroxide is a 1-. After I do my crisscross, I get KOH. Okay, so once again, we know that two things are switching. For me, the easiest is just to switch the two positive ions there. And what I'll get is I will get calcium with hydroxide. Okay, once again, the charges always stay the same. And I would get potassium with bromine. Okay, so I'm going to do my crisscross and I would get Ca(OH2) and I would get potassium bromide. Okay, now once again, you don't have to include this top part. Okay, I'm just doing it just to show you kind of the mechanism on how to do it. Once again, what I'll be looking for is just your final equation. Okay, so once again, let's go through our polyatomic ion sheet. Okay, that's how we'll figure out what our states are. Okay, so I'll go walk us through a couple, but then once again, you should have already done this. So calcium bromide, okay, so here's bromine. Okay, calcium is not any of these, so it is all others, so it's soluble. So we would have aqueous there. Okay, I'm also just going to skip down to potassium bromide because I'm in the same section. Okay, so for bromine, I have all of these. Potassium is not any of them. It's all others. So potassium has to be soluble as well. Okay, so this potassium bromide is also an aqueous. Okay, so hopefully that makes sense. Next, I'm going to look at my hydroxide. So I need potassium hydroxide and I need calcium hydroxide. So let's go ahead and let's see if we can find both of these here. So my hydroxide, okay, potassium is an alkali metal. It's in the first one, so it is soluble. So potassium hydroxide is AQ. Now the next one I'm looking for is calcium. So let's see if I can find this here. Okay, so for hydroxide, well, I don't see any calcium up here, so it has to be all others. And this one is low solubility, so I would have a solid there. Okay. Now, because I have a solid, well, is this reaction going to take place? Yes, it is. Okay, and that's what we would have there. Okay, and once again, you would have to balance your equation in order to get full marks, but I'm not going to go through that balancing because that's what we would have had. Okay, so those are some examples. Okay, now once again, if by chance, okay, we'll try to find another example where we have all aqueuses. If by chance all of your products were aqueous, okay, you would say that no reaction takes place. Okay, so once again, if you have potassium, if you have that there, if they were all aqueous, you would have no reaction being taken place. Okay, so let's go back to our lesson here. Okay, so that's what we call our precipitate reaction. Okay, that's our example that we just completed. Okay, now you'll see in our lesson as well that we have something here called net ionic equations. We are going to be looking at this in Unit 4. So for now, don't worry about that. You can cross these out. Okay. But what I want us to do, we're going to go through a couple more examples. We're going to get a little bit better at doing this because we're also going to see some gases as well. Okay. All right. So let's try another example here. Actually, what I'm going to do is I'm going to keep this video here. I'm going to start a new one, and we'll keep on going through.